Hello everyone, good morning. So today we are joining with this session. We are discussing about Dibal-H. Okay, about Dibal-H. So join fast everyone. Okay, we'll start within 2 and 3 minutes after joining everyone. Okay, keep sharing this live and like this live. Okay. Everyone please join fast. Everyone join. Good morning everyone. Good morning everyone. Just join fast and tell me one thing that my voice is clear or not. Tell me one thing that my voice is clear or not. Reagent boy, hello. Okay, thank you. Good morning, good morning. Everyone join and like the live. We will start within 2 and 3 minutes. Okay. Just tell me my voice is clear or not. Just tell me my voice is clear or not. Hello. Mamalla. Okay, the voice is clear. So we have already talked about like lithium aluminum hydride, okay, and as well as we have already talked about sodium borohydride and its derivatives. Okay, so lithium, there are some certain difference between lithium aluminum hydride and sodium borohydride, as well as the reactivity and selectivity we have talked about. Okay, so is there any problem regarding that? You can ask me now. Is there any problem regarding that, regarding previous lectures? You can ask me now. Okay, and many of you attempted the last attempt of CSIR NET exam. So how was it? The scorecard has been published already. The scorecard has been published already. How was it? Any of you who got 90 plus or 100 plus, there is a possibility to get lecturership and as well as JRF. So if you are not, then go for this time 102. Very good, 102. If you have 102 marks, this is a very good marks, but little less for JRF if you are from general category. Okay, it is quite less, little less, not so much. Okay, but you got lecturership easily. Okay, for general it will be 95 and something. 87.5 general. This is also the cutting edge point. Okay, this is also the cutting edge point. For general it is 90 above. Okay, for general it is 90 above. In previous years it is 90 above for lecturership. Okay, so now what how much you think about your preparation going on? Yeah, We'll start it in 2 and 3 minutes. 2 and 3 minutes, no, we'll start it in 1. Yes, Dhanashri, good morning. Good morning, everyone. Keep sharing this live and like this live. Okay? Keep sharing this live and like this live. We have already talked about our in our previous lecture about lithium aluminum hydride and sodium borohydride. See, lithium aluminum hydride and sodium borohydride, I have already told that they are nucleophilic hydride donor. Okay, so what is nucleophilic hydride donor? You know about that. Okay, so many of you are watching this live, please like. So nucleophilic hydride donor means that the boron or the aluminum, the metal ion we have seen that the metal atom we have seen that will be negatively charged. Okay, that is negatively charged. But today we are talking about Dibal-H. Okay, today we will talking about Dibal-H. Now Dibal-H is like electrophilic hydride donor. Dibal-H is like electrophilic hydride donor. Okay, so it is you can say easily that it is the also Dibal-H has same kind of thing like our lithium aluminum hydride and sodium borohydride. Okay, so it is same thing as lithium borohydride and sodium borohydride. What happened? Okay, so it's a conductor of aldehyde. Very good. So Dibal-H is basically a conductor of aldehyde. Like the lithium aluminum hydride, we know that it is a conductor of alcohol. Okay, we told about that it is a conductor of alcohol. Similarly, Dibal-H is a conductor of what? Is a conductor of aldehyde. Okay. So similarly, Dibal-H is a conductor of aldehyde. Now about we are talking about Dibal-H. So we are talking about Dibal-H. So as you know, I have already told that in this session or in this case in this lectures, we are simply talking about just a second. Okay, we are back. Okay, so in this lectures we are simply talked about how to unblock your fear about CSIR NET examination. Many of you have been done with that. Okay, you have already has good marks in CSIR NET examination, but it must be better. Okay, and busting all the myths about reagent and reagent chemistry and solving questions that are most important for Dibal-H today. Okay, so from previous lecture, so tell me what will be the product of the following reaction. some previous lecture in sodium borohydride. Okay, tell me what will be the product of the following reaction. Okay, reagent boy, it's okay. We are going forward to the June attempt. Okay, so go forward for the June attempt and you will succeed. And it if you have in this attempt this such of numbers, okay, so you will get a good number as well as a good rank in June. Okay, so what will be the answer? Dhaneshwari C, Spreadfish D, Chem Pacific what? Chem Pacific D, Muhammad A. So what will be the answer? What is this reagent name? What is the name of this particular reagent? There is a name. There is a name of this particular reagent. Okay. D. Yeah. This is called Luce reagent. Okay. This is called Luce reagent. Very good. So Luce reagent means. So Luce reagent means in general what will be the NaBH4 do for this particular reactant? For NaBH4 this there is aldehyde and there is ketone. There is what? There is aldehyde and there is ketone. So as we know that aldehyde is much more reactive than ketone. So the NaBH, or if you use NaBH4, then aldehyde will reduce, not keto will not reduce. Okay, but in presence of CCl3 methanol H2O, that means for Luce reagent, the reactivity order we know that it will react with alpha beta unsaturated ketone first, then ketone, and then aldehyde. Okay, so it will reduce keto first rather than aldehyde. So correct option will be option D. Correct option will be option D. Okay, so that's the fine one. Next we go for Dibal-H. Okay, we go for Dibal-H. Dibal-H is nothing but diisobutyl ammonium hydride. Diisobutyl aluminum hydride. Okay, so this looks like this kind of thing, as also known as Dibal-H or Dibal. Okay, so Dibal can purchased commercially as a colorless liquid. Many of you know about that. Okay, many of you know about that Dibal-H can be purchased commercially as colorless liquid. It is more commonly purchased as dispensed as a solution in an organic solvent such as toluene and hexane. So it is why it is in toluene and hexane. See, any compound that is related to Dibal or aluminium or boron, you know it has a high aptitude for getting dimerization. Okay, it has a high aptitude for to get dimer. Okay, so that's why it becomes solvated in toluene and hexane. It is an electrophilic reducing agent, as we know that lithium aluminum hydride and sodium borohydride is nucleophilic hydride donor, but it is an electrophilic reducing agent, whereas lithium aluminum hydride can be thought of as a nucleophilic reducing agent. Okay, so nucleophilic reducing agent, what is that? That lithium aluminum hydride and sodium borohydride. Now why it is called as electrophilic reducing agent? As I told you that aluminum, you know, aluminum and boron are group 13 element. As I told you, they are very poor. They are very poor. So they are very poor. Poor, yeah, or electron deficient species or electron deficient atom. Till it get 3 bonds. Till it bonds with 3 atoms. Okay, but when it get get a bond with 4 atoms, it becomes rich. It becomes electronically rich. So when we have 4 bonds attached to aluminum or boron, it becomes rich and acts like nucleophile. But in Dibal-H, you see that there the aluminum is attached to 3 bonds only. So it will act as a poor compound, electronically poor compound. Understood, everyone? It will act as a electronically poor compound. Understood? Yes or no? Understood? Yes or no? Okay. It has a vacant p orbital, electron deficient, therefore it is more reactive towards electron rich nucleophilic carbonyl compounds. Yes, very good, very good. You are understanding all the things, very good. Okay, so we can say that it will be an electrophilic donor. Okay, electrophilic hydride donor, as well as we can say that it will be more reactive than lithium aluminum hydride or not. See, it will be more reactive than lithium aluminum hydride or not. Tell me, which is more reactive, lithium aluminum hydride or this? Which is more reactive, lithium aluminum hydride or this Dibal-H? Tell me, which is more reactive? Tell me. Lithium aluminum hydride, very good, very good. So lithium aluminum hydride is more reactive, that's why it is less selective. It will reduce everything, but it is more nucleophilic. That's why it is less reactive, as well as it is more selective. It will selectively reduce many more compounds, carbonyl compounds. It will selectively reduce the particular carbonyl compounds rather than any carbonyl compounds like lithium aluminum hydride. Okay, it will selectively reduce. So we will go for the reactions now. So this is very easy, interesting. Okay, this is very easy and interesting, guys. So yeah, more nucleophilic, very good. So so how to prepare this Dibal-H? So there is a simple, very nominal manner to prepare Dibal-H. The preparation of Dibal-H by heating of triisobutyl aluminum, itself a dimer, to induce beta hydride elimination. See, this is triisobutyl aluminum, and after that, if you heat this, we will get Dibal-H. Okay, with isobutene. If you heat this, we will get a Dibal-H with isobutene. Okay, so so here we can prepare Dibal-H. Now we can say that the reduction properties of Dibal-H. So it behaves like lithium aluminum hydride at high temperature. Like when we use lithium aluminum hydride with high temperature, it can reduce carbonyl compounds with epoxide ester acid chloride, so corresponding to alcohol. Okay, so this is the property of lithium aluminum hydride, that carbonyl compounds, epoxide ester acid chloride, it corresponds to alcohol, amide and nitrile, it corresponds to amine. But when it comes to Dibal-H, it behaves with alkoxy aluminum hydride at high temperature. Like carbonyl compounds and epoxide corresponds to alcohol. Okay, ester acid chloride, amide and nitriles corresponds to aldehyde. Okay, so carbonyl compounds like aldehyde, okay, aldehyde and ketones, and epoxide, which corresponds to alcohol. Understood? But for ester, acid chloride, amide and nitrile, in presence of Dibal-H, it corresponds to aldehyde. Okay, understood everyone? Everyone understood this? So what is the particular criteria of Dibal-H? What is the particular criteria of Dibal-H? So we can say that it is widely used for making aldehyde. It is widely used for making aldehyde. Okay. Okay. So if you understood this, please like this live. If you understood this, please like this live as soon as possible. Okay. So what is the mechanism? Why it is go for aldehyde, not for alcohol? See, at first we know that aluminum, this Dibal-H is a electronically poor species, we know. So it will take electron from anything. So the oxygen is here, for ester oxygen is here, will give the electron to aluminum and make this bond. Okay, after that aluminum have 4 bond, After that, after this addition, aluminum had 4 bond. Okay, so when it has 4 bond, it becomes rich, and it will give its only one hydrogen to that carbonyl group. Okay, so Dibal-H has only only one hydrogen, so it will give one hydride to that carbonyl compound. So after that, this will happen. Now in presence of water, what we know, if a carbon attached with 2 oxygen OR, it's like acetal, we know it's like acetal. So in presence of water, it becomes carbonyl group, okay. So as we see that the 2 oxygen group or 2 OR group in presence of water becomes carbonyl group, and we will get aldehyde, okay. So this is the mechanism, very simple mechanism, you know, okay. So just you have to know what will be the intermediate this, Now there is some notes, you have to know that the esters, okay, so the esters are selectively reduced to corresponding aldehydes at low temperature. In low temperature, it will be selectively reduced to aldehyde, okay. The esters are selectively reduced to aldehyde. Now there is a catch, that why it is low temperature? Because I already told that in high temperature it will act like lithium aluminum hydride. In high temperature it will become like lithium aluminum hydride. Okay, in substituted form like aluminium 2 isobutyl H2. Okay, so that's kind of substituted form. But but in low temperature, the temperature must be taken as minus 78 degrees centigrade. You have already seen when Dibal-H we are using in many reactions, in many questions we have already seen that in Dibal-H we are using minus 78 degrees centigrade. So that's the reason. The Dibal-H transfer one hydride to the ester group and forms tetrahedral intermediate which is stable in low temperature. So there is one more reason that this intermediate is stable in low temperature. Okay, stable in low temperature. The hydrolytic workup, the intermediate gives the desired aldehyde. So after this workup is needed. Okay, so this workup is very important for this particular reaction. So after workup we will get aldehyde, otherwise it will stop in this particular step. Okay, so come again. So here what happened? That there is acid chloride and there is NO2. So what will be reduced in presence of Dibal-H? So acid chloride will give this aldehyde. Will get aldehyde in many of cases. Similarly for ester also will get aldehyde. Okay, and but see, there is nitrile. Now nitrile in presence of lithium aluminum hydride, what it will be going to reduce? So nitrile reduced to amine CH2NH2, but in presence of Dibal-H it will be reduced to this one and CH2NH2. Now remember one thing, this is a very important statement. That this product can be done for further reaction, okay, like you know pinacol type reaction, if you use HNO2 here, we will get a product like this, OH, and there will be positive charge. Okay, then oxygen will come and this happened, and we will get the final product this. See, very interesting reaction. So using CN, using nitrile group, we can go further for this cyclohexane, one carbon up. Okay, understood everyone? Understood? If you understood this, so send emojis in the chat. Okay, am I audible everyone? If you understood this, send emojis in the chat. Hello, Kim Pacific, Pooja, Mohammad, Dhaneshwari. Okay, very good. So this is the reactions. Now comparison chart. This is a very important chart for you guys. This is a very important chart for you guys. Like see, if you have a compound which have an ester and which have a ketone, which has a carbonyl group ketone and which have an ester. So if you use sodium borohydride, it will only reduce the sodium borohydride in presence of methanol. Okay, sodium borohydride in presence of methanol, and after workup, see, here is the catch. We know sodium borohydride will not reduce ester, but here is the catch. It's after workup. We are using workup. So after workup, this ester becomes aldehyde. So therefore, the only group reduced is the ketone to alcohol. If you use lithium aluminium hydride, both will reduce. If you use lithium aluminium hydride, both ester and ketone will reduce. Now, in presence of Dibal-H, this will reduce, this ketone will reduce to alcohol and this ester will reduce to aldehyde. This ketone will reduce to alcohol and this ester will reduce to aldehyde. Understood? Similarly, if we use this diol. So in presence of ester and in presence of ketone, the diol will protect the ketone first. What will happen? That the diol will protect this ketone first. This one, okay, and this will remain same. Okay. So the diol will reduce this and this will remain same. So after that, if you use Dibal-H, it will reduce to aldehyde. Okay, and finally after H3O plus, we will get this. Okay, we'll get this product. Okay, very easy. And using red aluminum with the keto will reduce and this will reduce to aldehyde. In using red aluminum, it will act like sodium borohydride in after workup. Okay, so this is the thing. Okay, so before starting our questions, so one more thing left. That is this is what? Lactone. Okay, so this is what? Lactone. Now in presence of lithium aluminium hydride, red aluminium means it is you can say red aluminium means it is a reactive aluminium, or we can say in simple words, red aluminium means we can say that it will activated aluminum. Okay, it will act as activated aluminum. Okay, as a reducing agent. We use it in Dibal-H. This is aluminum, we know, Dibal-H, aluminium diisobutyl. So this is red aluminium is also like activated aluminum. Okay, so in presence of lithium aluminium hydride, this bond breaks and we will get the product like this. Here will be OH group, okay, and here will be OH group, diol. But in presence of Dibal-H, what will happen? Same thing happened. In presence of Dibal-H, same thing happened. This will broke and we will get this and we will get this only. Okay, so we will get this and this, not going for diol. It will not go it will not form diol. Okay, understood? Okay, so before starting our questions, you can go to our website. There are paper analysis of at least of last 12 years, including the last year, including last examination. The last 5 years cut off, last 12 years previous year question and exam related all information. You will go to ifasonline.com. You will go to ifasonline.com and it is completely free. You can access it free and with valuable resource for the exam success. It is completely free. Okay, so go to ifasonline.com. okay, so I don't have to say it to you guys. Okay, I don't have to say it to you guys. You all know, you are good students, you are know about your career and all. Okay, you are curious about your career, so you will go to ifasonline.com. okay, see next. So our first question of today is going to do this. So this is our first question. Okay, so tell me what will be the answer of the following particular question. See, what is here? The major product obtained the following transformation. The first step is Dibal-H, second is TBS OTF. TBS is nothing but tributyl silyl OTF. Like TMSCl, we know TMSCl, trimethyl silyl chloride. TBS OTF is tributyl, that silyl silicon, and tributyl, and here it is attached to OTF. OTF is a good living group. It is a good living group, like chlorine here, TMC. Okay, so option 2 came from spurt piece. Anyone? It's a very easy question. You know this question well. It is a very easy question. Tell me anyone, option 2, what it will be? Option 3, what it will be? Tell me. Option 3, protecting group. Yeah, protecting group. Very good, Ganeshwari. Option 2. Anyone? Anyone? If you know this question, if you know the answer, tell me in the chat. Otherwise, send emojis in the chat that you are not fond of this particular question. Okay. So in my every lecture you will get new questions, not previous year questions. This is not a previous year question. It is the new questions you will get. Okay. Okay. Manisha Patel, option 3. Okay. So many of you are talking about option 2. Many of you are talking about option 3. So see, one more thing. See, the Dibal-H, in the mechanism we have already seen that here will be attached to aluminum, Okay, so the hydride will transfer to this position from backward side. The hydride will transfer its position from backward side, from backward side. So if the hydrogen will transfer from backward side, we will get this kind of product, this one, and there will be a O negative or O aluminum in the above position, okay, and there will be hydrogen, okay, and as well as O negative, and there will be hydrogen, okay, and there will be in the above position this thing, okay, this thing will happen. Now this one comes to place, that is OTF is TBS. So this O negative come to silicon, and this OTF will leave, this this one will leave. Similarly here also TBS OTF, so this will attack and OTF leaves. So what will be the product? Is that option 1? Tell me, is that option 1 or not? Is that option 1, option A? Yeah. So the correct option is option A. Okay, so whenever you have a question, just put it in your copy and done. Otherwise, you will not realize the stereochemistry of the product. Okay, so let's go for the next question. Next question is very easy question. Which of the following will be reduced by Dibal-H? Which of the following will be reduced by Dibal-H? Tell me. Which of these following will be reduced by Dibal-H? Is it nitrile? Is it ester? Is it acid group, carboxylic acid, or all of them? 1, 2, 3, 4. Tell me. All. Muhammad telling all. Anyone else? Anyone else? Four. Very good, very good. So Dibal-H is a machine of providing aldehyde. So CN will reduce to CHO, as well as ester or acid will reduce to CHO group, aldehyde. Okay. So the correct option is option 4. Very good, everyone. Okay. So there is a new thing came into place, that CSIR NET June 2024 aspirants, whoever will see this video or in the live lecture, you know that the duration of 6 months, the original price is 31,000, but you will get in and only in 8,000 rupees. The 12-month price is 47,000 and you will get it in 11,000. And if you want to go for 24 months for CSIR NET examination without study material, so you will get it in 18,500 only. So there is a 75% off if you use the code IFAS 75. If you use the code IFAS 75, the batch has been already started. The batch has been already started from 29th January 2024. Okay, so you can enroll to our site. Okay, enroll from our site. So there is a thing that you can go for study material, including study material. Okay, including study material, there is only 4,000 will be included in the price of study without study material. Okay, without study material. But remember one thing, there is 75% off. You have to use code IFAS 75. This is a limited time offer. So hurry up and join our sessions. There will be live sessions. Okay. So the perks I am talking about, you will get live lectures as well as the recorded version of that live lecture every day. After completion of that live lecture, instant. And after that you will get DPPs and PDF of that live lecture, as well as you have to give mock tests and everything. In weekly tests as they are, mock test, full tests are there. So it is a complete package to get your dreams succeed. Okay, so go to ifasonline.com, or otherwise you can call to this number 9172266688. Okay, so let's go further. Next question. Next question. Let's the timer on. Okay, let's the timer on. Okay, let's the timer on. Okay, I have turned on the timer. Let's tell everyone what will be the answer. Why can't diisobutyl aluminum hydride, or is Dibal-H, reduce an aldehyde but it cannot reduce an ester? It is reduced to aldehyde. It can reduce aldehyde to what? Alcohol, but it cannot reduce aldehyde to ester. So what is the particular reason? Tell me. Tell me, you have only 1:30 seconds. So option 3 form 45 spurt piece C. Everyone else, tell me what will be the answer. What it will be the answer? Two answers only came. So 2 minutes done. Tell me. Is that a very hard question? Is that very hard question? Not. So tell me everyone, what will be the answer? Is that very hard question? It is not a hard question. Tell me everyone, what will be the answer? Tell me everyone, what will be the answer? It is not a hard question. See, why can't diisobutyl? This question, I think the question is visible. I think, okay. So I don't have to added this. Okay. So why can't diisobutyl aluminum hydride, that is Dibal-H, in basically Dibal-H reduce an aldehyde, but it can reduce an ester. So the ester is more reactive functional group than aldehyde. It is not. There is there is only one equivalent of hydride per Dibal-H molecule. It is the correct answer. Dibal-H is a weaker reductant than lithium aluminum hydride. It is correct, but it is not the reason. It is correct, that is a weaker reagent, but it is not the reason. Okay, so it is incorrect. Dibal-H actually can reduce aldehyde, but the aldehyde but the aldehyde does not form at cold temperature. No, aldehyde formed in the cold temperature, not in high temperature. Okay, so it is also incorrect. There is only one equivalent of hydride in Dibal-H. That's the correct answer. Next question. Tell me what will be that. Very important question. The major product obtained in the following reaction. Tell me. Very important question. Tell me what will be the answer. Tell me what will be the answer. Acha, the timer is already in loop. Okay, tell me what will be the answer. Very easy question. It's a very easy question. Tell me. B is the intermediate. Tell me what will be the answer. B is the intermediate. Tell me what will be the answer. Only one answer. I got only one answer. Tell me what will be the answer. Spurt piece 3. 45 4. Everyone answered different answer. Everyone has its own different answer. Huh? What will be the answer? Okay. Everyone give a different answer. So see, in between pH, CHO, H plus, what it will happen, that this thing. Okay. So in there will be what happened. See, there will be what happened. The protection will happen. Okay. So this one, and there will be phenyl group. Okay. There will be phenyl group. The option 2 will be given. Okay. The option 2 is given. Okay. The option 2 is given. Now after that what happened? In presence of Dibal-H, what will be there? Tell me. What will be there? In presence of Dibal-H, what will be there? Tell me. What is a 6-member intermediate? Yeah, 6-member intermediate, I know, but what will be the product? In presence of Dibal-H, what will be the product? See, in presence of Dibal-H, this bond will break. Any of them will break, but this will be the Lemieux reduced, so this will be the this will break. So we will get this one, and there will be this, and there will be oxygen, and there will be phenyl. So this product, no, not this product. After that we will get, there will be OH. One more I think, carbon. One more I think, yeah, there will be OH. Also there is one more, yeah, okay. So this one, after that using CrO3, this will be oxidized, and we will get oxygen, there will be phenyl, and there will be double bond OH, oxidized, over oxidation occurs, and we will get the product 3. We will get the product 3. Okay, CrO3 oxidant, OH to COH, yes, correct. Ring open on most stable side, yes, very good, very good. Okay, last question of today. Already told. Last question of today, already told. B, spurt piece B, 45C, shopping area B. Already told, I have already told this question, what will happen. Already told. So this bond will broke, this bond will cleaved, and we will get, in the above side it will be aldehyde, and in below side it will be alcohol. Simple. So correct answer will be B. Okay. Okay, there is a talking about a gate exam. Okay, gate examination, it's little bit tough. It's little bit tough. I was fond of that. The gate examination is little bit tough. Like it is the MCQs are very very problematic. I oh, what I came to know that MCQs are very problematic. MSQ, sorry, not MCQ and MSQ. There are 19 MSQ in GATE examination in the last. So to overcome GATE examination or to overcome MSQs, okay, aptitude was tough. Okay, MSQs are from organic. Yeah, so I know MSQs will come from organic because see, there it is the era of organic chemistry where all of the simple questions have been done from the gate point of view or from the net point of view. It must go for the intermediate section and it must go for the MSQ section. So you need to know the mechanism clearly, well cleared. You need to know the particular theory, particular selectivity well known. Okay, well known. See, I regret about my silly mistakes era. Okay, so you have to know that, and that I see that's the problem. Okay, so I am not talking about the problem, I am talking about the solution. How to go for the solution of this particular problem. There is no such a solution. There is no such a solution except you have to do practice more and more. You have to do practice every day, at least 5 to 10 questions. Today we have done 5 questions. They are new questions, completely new question. Okay, good morning Kushi Vaishnav. So they are completely new questions. So similarly you have to do at least 5 to 10 questions from every segment, like physical, organic, inorganic. From every segment you have to do daily 5 to 10 questions. You wanted to know how to get new questions, you can visit our website. If you have your scorecard, like if you have your scorecard of NET examination, you can come to our website. It can predict your rank also. Okay, it can predict your rank. Otherwise you can go for our website. There are freely available many more questions, and also this PDF of today's lecture also freely available in that particular app and or in that particular website, that is ifasonline.com. okay, so you can come there, you can register it and practice it out. Okay, daily practice is a habit. It must be a habit for your aspirants for next 6 months only. Okay, try to get a habit of doing 5 to 10 new questions daily, regularly. Okay, so that's the success mantra, you can say. That's the success mantra of getting this one. Congratulations ERA for NET. How much you got? Who is ERA? I don't know. Okay, so today's lectures is done. We'll come tomorrow with like selenium dioxide. Okay, with selenium dioxide. So for today, sayonara. Okay. And all the best to everyone.